So this is question 6 that reads as follows. It says, consider the graph of f of x equals to 3 times b to the power of x plus q and its asymptote y equals to negative 6. The graph of f cuts the y-axis at the point 0 and negative 3, 6.1. If f of x passes through another point with coordinates 2 is to 6, find the values of b and q. Now, the basics of an exponential graph are not that complicated, right? You should know by now that if somebody says y is a times b to the power of x plus q, that this number here is the asymptote of the graph. So if you've seen it before done by anybody and you know this, you shouldn't have any problems. Already I'm looking at what is given to us. We're given f of x. According to what is given here, we can basically say y is 3 times b to the power of x plus q. Our q is definitely supposed to be minus 6 because we were told that the asymptote of the graph is at y equals to negative 6. So this is like a knowledge question. If you know what an asymptote is and you know the equation, you will be able to find a solution without any problem. So that's the first thing that I've done. Now, the second thing that I also want to emphasize is people don't give you things for no reason. There's a reason why they're telling you something. So if you get stuck, always ask yourself, what was the purpose of what you told me so far, right? What did you tell me? Why are you even telling me that? And how can I use that to try and solve the problem? Very important. So now, the given information on this 6.1 question, right, is the fact that the graph passes through some random point. So there's a point on the graph with coordinates 2 is to 6. Now, I'm sure by now you appreciate the power of substitution. I'll take 2 and put it as x, and take 6 and put it as y, and the only unknown that is going to be in this equation will be the value of b. So the take home from this particular question is an asymptote, very powerful. Secondly, substitution. Always keep that in mind. So there's a 6 here, 3 times b to the power of something. What is something? Something is 2 minus what? Minus 6. Now I'm going to add 6 on both sides. When I add 6 on both sides on the right hand side, I'll be left with 3b to the power 2. And then if you add 6 on the left, it becomes a 12. Divide both sides by 3, you get 4 is b squared. Now, grade 12s, at this point, I don't know what the correct b value is going to be. In this case, if you take both sides, the square root of b squared, you'll get a b. The square root of 4 is supposed to give you plus or minus 2. The accepted answer will be a positive 2. Okay, so just be careful of what is the value that you are picking as your b value. Generally speaking, the base is always a positive value, but in the context where I was looking for this unknown a value here, if this a value was the unknown, the decision that I would take will depend on the shape of my graph. If it's increasing, that value would be a positive, provided the graph is increasing to the positive direction. But if it was decreasing, going negative, then I will take the negative solution of what we're looking for. But as far as b goes, b will always be a positive value, greater than 1. Right, 6.2 says, write down the range of the graph of h of x. So we're going to find the range of the graph of h of x, okay? Very awesome, no complications. But what is this h of x that they're talking to us about? We need to understand the transformations that have occurred on the graph of f to try and create the graph of g. So what am I writing? I'm going to first start by writing 6.2 and say, remember, we are now asking you for the range of the graph of h equals negative f of negative x. So let's discuss these transformations. I like the questions you sent through, guys. We discussed moving stuff up and down. Now we're discussing reflections, okay? We are discussing reflections. So if you think about it, this negative x here on your x, remember the graph comes from f of x. Now, if you take x and you change it to a minus x, what you're effectively doing just on this part, what they're doing on the graph of f, they are reflecting it, okay? Reflection by the y-axis. If x changes sign, we are reflecting by the y-axis. What's the implication of that? It means our original graph, okay? If the y-axis is here, okay, and the graph was maybe like this, we're now going to have it going like that. That will be reflection by the x-axis. Please keep that in mind. But if I'm reflecting by the y-axis, I'll draw it in green for the y-axis. Let's keep the Cartesian plane in yellow. So if I want to reflect that graph, which is the graph of f. Let's say this is f. When I reflect it by x, it will create the current graph we are looking at the bottom now. But if I reflect it by the y-axis, it will create the green graph. So it will look something like that. Okay? Now, we are interested in the range. We can clearly see that the first thing they did is they're reflecting it by the y-axis there. That's why it's now minus x. The second thing is this one here, the one you have behind your f of x. So what reflection is that? This is basically as good as saying the whole of y is now becoming a negative, which means now we are also reflecting this. It's a reflection by what? By the, not the y, but by the x-axis. Since the y values, f of x is equivalent to y. So basically y is suddenly becoming negative, so you're reflecting by the x-axis. So what happened here to create the graph of h? The examiner did two transformations. Reflect the graph by y-axis, reflect the graph by x-axis. So it means if I have the original graph that we had, all right, this is basically the line y equals to negative 6. Our graph was literally above that line going like that, okay? So first transformation was reflection by the y-axis. That gives us the green graph. So I'm going to put the green graph here. That's because of the minus f of x that you have there. The second one, they're now reflecting it by the x-axis, so this thing is actually going to reflect, and it's going to be, instead of going up now, it will now be going that side. That means the range that you're going to basically have in this will just be range. This is where the solution is going to be for your range, right? It's all y values that are not bigger. It's not above now. It's now going to be below. What? Below negative 6. So very powerful. Please keep that in mind. It's very exciting. You can even do this algebraically by substituting negative where you see x, and by also substituting negative where you see the value of f of x. So very important for you to keep that in mind. So you could make a mistake and think that it's going to be with that negative x, but it actually has to be a plus instead of being a minus. So y is all values that are smaller than plus 6. Where am I getting it from? You can even do it. Remember, you put a minus. Your f of x was 3 times 2 to the power of x minus a 6. You are changing both x to a minus x. You'll get 3 times 2 to the minus x minus 6 with a minus outside. When you multiply in, you've got negative 3 times 2 to the minus x. And then when you multiply negative with 6, you're going to get plus 6. So remember, that is very important to keep in mind. We're no longer discussing negative 6 now. We're now noticing that the asymptote is now going to be at plus 6, and the graph is going to be below instead of being above. So algebraically, it also makes a lot of sense. So the range will be all y values that are smaller than 6. Suppose they wanted you to do the reflection by the line y equals to x. How would that look if they wanted us to reflect this graph by the line y equals to x? So let's go back to f of x. F of x, which is an exponential graph, has the equation 3 times 2 to the power of x minus 6. What do we want to do? We want to reflect it by the line. What line are we talking about? The line y equals to x. Now, what's the other way of saying this? Reflect something by the line y equals to x. The other way of saying that is just to say find the inverse of the graph of f of x. This is definitely one of the things we examine all the time. And you guys, because we're doing revision, you need to remember what is the process of finding the inverse, or what is the process of reflecting a graph by the line y equals to x. So what you will need to do is everywhere where you see y, you'll put x, and where you see x, you'd have to put a y. So how will this actually pan out? I'll best put y is 3 times 2 to the power x minus 6, and then after that, swap them. X is 3 times 2 to the power of y minus 6. So the idea from here will then be you trying to make y the subject of the formula. The questions that I'm currently working with could be a bit more harder. The ones that you normally get are easier, but the idea is the same. A lot of things we're discussing here involve transformations, reflection by the line y equals to x, you swap them, and then you try and make y the subject of the formula. Already in your mind, you know that it's going to be a logarithm. If you've been doing functions and inverses for a long time, you know that the inverse of an exponential graph is going to be a log graph. So let's see how the math is going to lead us in that direction. So what I'm going to do is I'll basically add 6 on both sides. I'll have x plus 6 is basically 3 times 2 to the power of y. I'll divide both sides by 3. I'll get x plus 6 over 3 is 2 to the power of y. Then I want to make y the subject. You guys will agree with me that the base is 2, so you log yourself in here. You'll have log on this side, okay? The base is 2, so I'm going to have a 2 here, okay? And then my argument is x plus 6 divided by 3. And then obviously we've got our y. Therefore, the equation of the inverse will always be what you're looking at right now in this context. It's going to be the logarithm with a base of 2 of x plus 6 divided by 3. Just an additional piece of information just for your education to say if they ever ask you for the inverse of a log graph, you can be able to move your way to this. And if you're starting with a log, they want the inverse, swap this, the x and the y values, and then try to make y the subject of the formula, you're going to end up with an exponential graph. Very powerful.